Well, good afternoon. I'm Eric Wesley, and I'm a Combined Arms Maneuver Soldier. I command Fort Benning, Georgia, in the Maneuver Center of Excellence. I'm glad you're here. We're going to talk about the next generation combat vehicle. And what I hope to do today is to establish a need for the next generation combat vehicle, some basic parameters that we are looking at when we design this combat vehicle, and the pathway ahead, and how we're going to go through a process of improving our acquisition efforts so we can put together a piece of equipment on the battlefield that's relevant to what the future tells us. Now, if you came up here and you saw this video playing, and you came here because you were going to hear about a combat vehicle, and if you're a gearhead and you're hoping to get right into some of the parameters of that piece of equipment, you might have been confused as to why you were looking at a concept described as cross-domain maneuver or multi-domain battle. But the reason I put that up there for you is because I want to tease your thinking, because the most important thing we have to consider when we're developing a combat vehicle is not the parameters of the vehicle, but the purpose that it's intended for or the problem that it's trying to solve. So let me go back, because there was a time when we did this right before. There was a time when we built combat vehicles and we had success, because those vehicles are in our fleet today. Go to the next slide, if you would. But let me just give you just a description. You know, this vehicle, this combat vehicle that we have today that we call the Abrams Tank, if you applied the same life cycle of the M1 Abrams to the M4 Sherman tank, it would have fought in OIF-1, and we would have divested it in 2012. So that's a vehicle that was built right and for the right purposes. But there were reasons it went well. And I throw this up here, and we're going to go back in time. I'm going to get to the next generation combat vehicle, but I want you to see why we think we did this right before, and maybe we should learn some lessons from it. The first is it was to solve a military problem. You know, there's been a lot of talk about the first offset, the second offset, what is the third offset? The reason the first and second offset were so effective is because they sought to solve a problem. And just like the M1 Abrams, we sought to solve a problem. So General Don Starry went to Israel in 1973 to take a look at what the Soviet satellite states were doing after the Yom Kippur War. And he came up with some conclusions, but one conclusion that he did not come up with is we just need to build a lot of tanks and a lot of artillery tubes. Because we had an enemy that had far more numbers than we had the capability to field. And a natural solution might have been to match them tank for tank and tube for tube. But he didn't do that. He said, we're gonna solve this problem a little differently. Two things that I just grabbed from that era. We're going to fight outnumbered and win, and we're going to defeat the enemy over the depth of the battlefield. And all of that became part and parcel of what we called air-land battle. We're going to fight outnumbered and win, and we're going to defeat the enemy over the depth of the battlefield. Now, what does that have to do with the M1 Abrams? Well, it has a lot to do with it. Fight outnumbered and win mean you have to have better lethality. You needed to be able to kill 3 of his in the time that you might be defeated as 1. But you also had to have protection, because ultimately you would want to be able to absorb anything he threw at you so that you can continue to fight him outnumbered and defeat him. You need mobility, because if you're going to fight him over the depth of the battlefield, you need to be able to move, and you need to be able to move deep and fast. So all of those characteristics drove us to build what we know as the M1 Abrams, a tank that lasted well beyond any normal generation of previous tanks, because it had superior firepower and fire control. It had superior protection, and it had superior mobility. So it sought to solve a problem. So that's point number one. The second thing I would talk about is, you know, our acquisition process was a little different back in the day, and this is before Goldwater Nichols and a number of other initiatives. So I'm hoping Julie Hill will come here in a minute, but I'm not going to compete with her. If Julie Hill's here, she's not going to get up. So our acquisition system was different. And it's just some key points that I would put out here is these are the things we need to remember. But it was a priority for the Army. Leadership was involved. There were necessary authorities to make decisions across schedule, cost, and performance. You had continuity of leadership in General Otis, who was there from the beginning all the way to the fielding. And then, of course, they were empowered to make decisions. So 2 points. One, we sought to solve a problem, and we had a means of authority in small circles to make decisions. So I say all that up front to say that's the way we need to look at some of these problems. Now let's look at what we're going to talk about in terms of what the era looks like today. But one thing I would point out as it reflects the problem, how many of you here are hearing your senior leaders saying the problem today is that we need to fight outnumbered and win? The problem that General Milley always talks about is the overwhelming numbers, and we need to be able to fight outnumbered and win. You don't hear that, right? So that means what the point is, we don't want to just go and build a better mousetrap. Because we could very easily fall back into a position where we build without which we already know. In fact, when we first started looking at this, if you looked at the POM line, because the POM means everything, the label for the next generation combat vehicle was future fighting vehicle. And if you followed that line, the way the human brain works, we could very easily have just built another fighting vehicle, just like the one we've got, but more improved. So we relabeled that because we did not want to predispose the decision. We did not want to lead the jury to what the outcome would be. It's not called a next generation tank, and it's not called a next generation fighting vehicle. It's called a next generation combat vehicle. So it doesn't lead the jury. So what does the world look like? Well, you saw the video. If you got here up front, you saw that video, but I'll just reinforce some of the points. If you go to the next slide. I won't go through all of the details, and I would probably just lead you to these elements right here. But these are things, if you've listened to the Chief of Staff of the Army, if you've listened to the TRADOC commander, if you've heard the descriptions of multi-domain battle, these are the characteristics of war that we're seeing right now. And all of them have implications for that problem we're trying to solve, that combat vehicle that we want. The first thing is all domains are in play. The second point is what has changed since the 1970s when we went over and looked at our opponents? We're not forward deployed anymore. So we don't have anything that approaches a home field advantage. We don't even have the ability to be pre-deployed in the event of some kind of problem in any of the continents. In fact, we have to deploy. Irregular forces, hybrid forces creates confusion on the battlefield and a 360-degree non-contiguous battlefield that we have to be contend with. And then the next one, the enemy's in the network. If he can challenge all domains, you can be pretty certain that communications will be a problem, and it will preclude us from having all the certainty that we have today. One of the things that we have gotten used to in this generation of fighting is we have ubiquitous and constant connectivity. There's never a time when we are not connected. But in this environment, we expect there to be a significant problem with our ability to communicate. Long-range precision fires. If you listen to the Ukrainians, long-range precision mass fires that are exceedingly lethal. Which if you heard General Milley a year ago, he would tell you that we have to continually be moving our formation. That a unit that stays static for more than 2 hours dies. That is fundamentally different than what we've experienced over the last 15 years. And then this issue of troop density reduced, or this idea of dispersion is critical. Something that you really got to come to grips with. If you look at armies over the legions, you know they get smaller and smaller and smaller and more capable. Units or armies get smaller and smaller and they get more and more capable. And capability continues to migrate downward. Partly due to cost, but partly due to lethality. So these describe some of the changes in the character of war, and you've heard them all for quite some time, or at least over the last 2 years. But I then take it to the next step, and I'd ask, okay, so what are the implications? What are the implications for how we're going to fight in that environment? If you go to the next slide. And the first point I would make here, in fact, go back one, I'm sorry. If you didn't pick up the first line, I should have emphasized that up front, and that is that our adversaries have studied how we fight. And I want to reinforce this, and I apologize for not hitting it up front. Our adversaries, our peers, have studied how we fight. And they've watched us for 20 years. And one of the things that our near peers have seen is if you let the United States and its coalition partners and allies stack metal in a given theater over a 6-month period and allow them to initiate the fight on our own time, nobody wants any part of that because it never ends well. So if you look at recent engagements that we've been in, we've had months to put equipment into a foreign theater. That is an assumption we can't make anymore. And if we go to the next slide, this will make more sense. But one of the things, and all the investments that our near peers have gone after, in the end, builds standoff for our near peers. If you put it in one word, what the Chinese have done, what the Russians have done, and others, is they've invested in an ability to maintain standoff relative to the United States and their coalition partners and allies. And this illustration right here just shows you 4 tiers of standoff. And this imagery is merely said, gives you the challenge on what in a theater we need to deploy to from home station. But that standoff starts in this environment. Information operations, cyber attacks. And if you don't think that has an effect, regardless of what we think the outcome or the facts were as it relates to our last election, just the question as to whether the Russians were engaged in our election causes deception and disruption within our own government. So the standoff starts with just the debate and the discussion as it relates to social media. So they start in social media. They start in the information environment. And the next thing is they've invested in this whole idea of integrated air and missile defense. And you've heard us talk about A2AD, which means getting to the theater and getting set prior to any conflict is already a challenge. And as I already said, we don't have home field advantage. We have to get across whatever ocean we need to get to in order to get to a theater of war. That's different from the 1970s. I already mentioned long-range precision massed fires, the lethality of which we have not seen in our generation. And then finally, this whole idea of hybrid warfare, which confuses us even before we get to any kind of phase 3 op. So what that shows you is that what we have is an enemy who are an opponent, a near peer, who has created standoff that makes it difficult to get into the fight. So let's look at the logic trail of where that brings us. If you go to the next chart. The logic trail and where that brings us in terms of the things that we want to emphasize as it relates to the next generation combat vehicle. And this is just a very simple flow chart. I've talked you through the operational environment. And the operational environment is one that has standoff. It's incredibly lethal due to long-range precision fires. We do not have home field advantage. It's a hyperactive battle space and non-contiguous. If that's true, this is the way we're going to end up fighting. We'll have to be dispersed at great distances. I said non-contiguous. We also have to understand the fact that we'll be semi-independent. And if you look at some of our maneuver concepts, we will have brigades that will operate semi-independently. Why semi-independent? Because if you're at extended ranges, dispersed, and do not have communications, you by definition are independent. So what does that mean for a combat vehicle? So what we've done is we've put together a team, which I'll talk more about in a minute. But this team has developed really what we're talking about is the 4+1 key enabling technologies. If you're looking to build a combat vehicle, there are certain constants which we'll talk about. But what's unique about this vehicle, what will be unique about the next generation combat vehicle, it will be one that optimizes these 4+1 enabling technologies, which I'll talk about in detail in a moment. But I'd highlight this point at the bottom, this yellow band, because in the end, the common thread across all these key enabling technologies is you have the ability, when you measure weight relative to capability, all of these technologies either improve that or extend it. Each is common with those 4+1 key enabling technologies. So let's look at Let's look at the details of that. Go to the next slide. So what I've done is I've listed the 4+1 key enabling technologies around the outside. And I'd start you on the upper right. Again, you want increased capability relative to weight. The vehicle protection, you know that the chief has emphasized this, and investing in active protection is critical. Now, why is this important? If you followed the history of the Abrams tank, it started when its original fielding right around 64, 65 tons. It's approaching 80 tons today. We cannot afford to take another plate of steel and put it on the front. We cannot afford to increase the weight of the Abrams because it's no longer mobile. You can't get it across key roads and bridges. You can't truck the thing. So just adding armor, passive armor, is no longer sufficient. So what vehicle protection systems, which is active protection in various forms, allows you to lower the weight and increase the protection of the vehicle by destroying rounds before it penetrates the vehicle. Significant investment for the United States, and I would argue we're a bit behind relative to our peers. Directed energy and energetics. I probably don't have to talk to you a lot we've talked about directed energy in these venues, and we know that lasers are up and coming. We also know they have limitations, but we have to have an ability to incorporate that tool and that weapon system against threats. Why? Well, there's a couple of reasons. One is, if you can get sufficient energy, which I'll talk about, you don't have to worry about the supply chain of the ammunition. So now you've got increased capability with reduced weight. So directed energy is critical, and in the near term, we may be limited in our ability to exploit maximum lethality out of those weapons, but they will be useful in various forms. What you could lose if you didn't pay attention closely is, we said, directed energy and energetics. And what's energetics? If you've studied energetics, it really just goes back to gunpowder. You know, what is that compound made of? And we think that there is an ability to increase the energy density just based on S&T work that we're doing right now, which does what? It increases chamber pressure, which increases the velocity of the round, which increases the energy at target. And if you can effectively do that, you can lower the caliber of the ammunition and miniaturize the size of the gun and get the same lethality. So directed energy and energetics, again, increases capability while simultaneously gives you a lower weight. Power generation and management. Probably the resource that we yearn for the most on the battlefield and is most difficult to move around the battlefield is this idea of energy. When you think of thousands and thousands of gallons of fuel that you currently have to move across the battlefield on a daily basis, being semi-independent doesn't look too optimistic at this point. So we have to solve the energy problem. Now, there are a lot of doubters out there, but there's also a lot of technology out there. Fuel cell technology, electric power, or hybrid electric power. And we're in an era where you've got Tesla, who only makes electric vehicles, and Volvo, who says they are universally going to electric vehicles, as is GM. At some point, the United States Army is going to do the same thing as Tesla's doing. We think that you can probably reduce the volume of fuel for an Armor Brigade combat team by 46,000 gallons a day just for the Abrams, if you had Abrams now with hybrid electric power. The point here is power generation and power management power requirements will only go up, and the need for management and generation will only increase. That also augments your work with directed energy. So we need to get after some serious work on power generation and power management. When we talked to Fort Lee about this idea of being semi-independent, I know that was a big ask and a big task for the logisticians. But we're already looking at options that will reduce fuel consumption in half. Advanced armor material solutions, again, more protection for less weight. It all goes back to more capability for less weight. And then robotics. By definition, if you've got a robot, you have no people at risk, so your capability is going up relative to weight. We think that we've got to get after this, and this transcends all of these, and so that's why we call it the 4+1. So all of these technologies, why is less weight critical? It all goes back to this point that I started with, that we are out of position, which means we need to get into position, and so having 80-ton tanks is not going to solve that problem for us. So we have to reduce the weight footprint in order to be deployable. The key point in the center here is, and I know there are some that would be doubters, and one of the first questions I'm going to get, and I'll take the bite out of it now, is how is this not FCS? We'll have to live down FCS until the NGCV is complete, so I'll just take it right now. How it's not FCS is that we think the purpose of the development of this NGCV is to optimize the 4+1 to the degree possible in the maturity of the S&T effort in order to make a decision to go to the next level. A couple points here. It is costly, as all of our industry friends would tell us. It is costly to do a developmental project. So when we do a developmental project, when we start over with a combat vehicle, we want that vehicle to be effective. And the chief uses the term 10x capability. So we want to optimize these to the degree possible, but we don't want to chase these technologies. And we might have been criticized under FCS that we chased unrealistic technologies. Let me go to the next chart. So this is a busy chart, but let me walk you through it. This is just a strategic roadmap. It's actually just a cartoon of how we are moving forward with NGCV. Now, if you've already heard the chief talk about this in various public forums, I know he will talk about it tomorrow. But originating with the Maneuver Center down at Fort Benning, we made a recommendation about 8 months ago to get after a different approach to building combat vehicles. Because we believe that you have to push down as far as you can the authorities and ability to decide on trades across cost, schedule, and performance at the lowest level possible. That sounds familiar because if we went back and looked at the success of the Abrams, that's one of the factors that made it so successful, is that we had the Armor Engineer Board out of Fort Knox, Kentucky, that was able to build the Abrams and make decisions across various performance requirements in order to deliver that vehicle. Well, at Fort Benning, we recommended that we put together a cross-functional team, not unlike the Armor Engineer Board. And we expect that we will have a charter and XORD signed soon, but we've already put together a provisional team that is going to be the cross-functional team for NGCV. And the purpose will be to optimize these key enabling technologies and to make trades collaborating with requirements, the PM, industry, etc., to make a realistic vehicle. So what this chart says is up on the upper left in that gray box, essentially it says, look, you got to first look at the environment and make a vehicle that solves the problem you're trying to solve, just like we did in the 1970s. But the other thing it does is it acknowledges there's common factors whenever you make any combat vehicle. There will always be certain common factors that you're tied to. So you combine the operational environment and those common factors, and that's how we came up with a key 4+1 key enabling technologies. The role of the director of the CFT, the role of the brigadier general who comes down to Fort Benning, Georgia, to lead the effort as an operator to develop the next generation combat vehicle will be to optimize the 4+1 key enabling technologies. And what the chart is intended to show is not all of them are going to get to the ideal state. Not all of them will be to the state that we would hope they would be in. But the role of the director is to hold accountable the labs and industry to stay on a tempo that allows us to make a decision to build a next-generation combat vehicle that is a 10x capability, or at least a leap ahead. Because what we don't want to do is build another tank just to build another tank. We don't want to build a Bradley just to build another Bradley. We want to build the next-generation combat vehicle that gives us overmatch. So the director will be held accountable or responsible for holding accountable the labs and industry to stay on path. We ultimately will make certain technology demonstrators, and that will inform decision point 22. Decision point 22 is a FY22 decision on an MDD for the next generation combat vehicle. So when you look at those 4 key enabling technologies and the robotic and autonomous systems requirements, that's not a lot of time, but we expect to make a decision on an MDD in FY22. Okay, I'm going to stop there, and I'm going to take some questions. And I know that General Burns has volunteered for the hardest question because I saw him searching Google over here. But the key thing here is what I want to do is communicate to you where we're at in terms of framing the NGCV challenge, that there will be some different efforts, that is, that we're going to establish this cross-functional team, and secondly, that we've defined the problem a little bit differently. Ultimately, we want increased capability for less weight. So with that, I'll take your question.
General Sidney Freeberg. Acting and the Chief of Staff both mentioned this cross-functional team idea with you at the NGCV as one of those top 6 priorities. What entities are on that team from the different stovepipes?
I don't think everybody got the question, but he's asking how the team will be built. Is that right, Sydney? And who will be on the team? Yeah, so if you go back a slide. Okay, so let me lay this out. So number 1 is the director of the NGCV CFT, or the Next Generation Combat Vehicle Cross-Functional Team, will be an operator. He will likely be an army officer from the United States Army, active duty brigadier general. So he's an operator. He's not an acquisition guy. He's not a budget guy. He will be somebody who is relevant right now in the force, who is leading soldiers or has led soldiers in combat. So it's an operator focus. Underneath that organization, we have to have, in fact, this is why we put this up here, we've got to have a mix of those who are in the requirements realm, those who are in the acquisition realm, and those who are resourcers. But it goes even beyond that, because it should also include industry. And we have some legal hurdles to get past, but the collaboration of these 3 teams in a tighter circle allows us to make quicker decisions. In terms of getting to 22, there's a whole lot behind this roadmap right here, and I would probably put you to sleep if I laid it out there for you. But what we see is that over time, what we need to do is do these data calls where industry and the labs will be held accountable to a timeline to report out where they're at on these various technologies. And as the S&T technologies evolve, the shape, both conceptual and literal, will adjust. In order to get us to a point in time when we can make a decision on tech demonstrators or an actual vehicle itself. I don't know if that helps, Sydney. It's a milestone right now in terms of the POM funding line that we're looking at right now for NGCV, and originally developed to say, will we go to a next generation combat vehicle, or will we stay the pathway that we're currently on with our engineer change proposal approach to Abrams and Bradley? No, this is a material development decision well before milestone C. Sir.
Sir Frank Herster, could this conceivably be one vehicle to replace both the M1 and the M2?
So I'm glad you asked that, sir. In fact, that's one of the reasons we named it NGCV. I'll be candid, when I first saw FFV, what my mind said is that everybody else's mind sees Bradley 2, or son of Bradley. I was, by the same token, not convinced as an armor officer commanding Fort Benning that we needed to make this about the next tank, because I wasn't equally not as convinced that we would have a tank with the next generation combat vehicle. If you look at the sizing capabilities that we're looking at, if you look at the technologies that we want to exploit, I believe it's conceivable that the vehicles could be one and the same. Now, I'm not suggesting that was what will be, but we wanted to name it in such a way that we didn't lead the jury, and that eventuality could play out. Now, if the engineering, the S&T maturity precludes that, then we'll just have to acknowledge that at that time. But that's why the next 4 years will be critical to get prototypes out in order to confirm or deny that. Does that answer the question? Okay.
Sir, if you believe there's 46,000 gallons of fuel savings per day to be had, is the Army willing to hedge that bet by turning future year savings into current year investment in the technology?
Okay, as an example?
If you're going to save money on the back end in the log tail for fuel costs, can you put that money in today to invest in electric?
I think you could, but I think we have a ways to go to make sure that's a good bet. The analysis that we've done right now indicates that's the potential that could be out there. And again, this is just one example. We've got fuel cell technology that we have to look at also. But the importance of power and power management is so critical that we have to go for these more radical ideas. And as we learn, I believe that you can make those bets. We're not there now. I think we could be there by the time we get to decision point 22. And there's other bets. It's not just logistics trail. It's bridging, right? It's trucking. All that might change based on the next generation combat vehicle you're going to make. Now, we also have to acknowledge that we currently have the Abrams for an extended period of time, so that'd have to be balanced.
Dr. Daniel Zahn, MITRE Corporation. So I'm wondering about the bridging technology, the midterm and the long term, because we do have the Abrams, we do have the Bradley, a lot like the M113 when Bradley came along. We did not get rid of the M113. We found another use for it. So what is the midterm and long-term strategy? So
that brilliant question. You know, we always have to remember that you have to have your feet both in long-term and short-term. None of us would neglect that idea when we look at our own investments. You have to have long-term investments, short-term investments. Investment in the future, development for the future today is tomorrow's readiness. So readiness is the number one priority, but futures is critical too because that's tomorrow's readiness. So this is a good question. It all comes down to a bet. To what degree do you think you are going to have to mitigate war and significant war in the next 5 to 10 years? And to what degree do you think it will be more lethal in the back end of that? A good insurance policy is to ensure you invest in engineer change proposals for our current vehicles. And if you look at our current investments, we're going to have the Abrams and the Bradley into the late 40s as it stands right now. So those vehicles are not going away, right? So this is the M4 all the way to 2012, right? So we will have those to the late 40s. What we don't have to do is invest a pure fleet across the Abrams and across the Bradley with all of our engineer change proposals. And so what we think we should do is leverage the savings on the ECPs that might have gone pure fleet and turn that back into NGCV so we can push on these key enabling technologies.
One follow-up. Do you foresee any technology reuse? Like the AMP-V is reusing a lot of the Bradley hull and chassis. So do you foresee the NGCV being able to reuse the Abrams in some sense or Bradley in some sense?
My hope in this 4+1 is that no major component from the current vehicle fleet would replicate itself on the next generation combat vehicle. That's where my mind's at.
Sir, as I look at the complexity of what you're working toward here, you've got a dimension of objectives and trade-offs, you've got a time element, you've got a changing technology element, you've got a cost element, and then you've got a complexity element. And I look at all of those, and then I remind myself of the F-35 debate. Maybe this is the tough question you want to hand off, but are there lessons from that exercise that you're applying to this? Really, because this is technology driven, at some point you have to draw the line and say we're not going to wait just a little bit more for this technology to develop. We're going to go with what we have today. And I see that in an endless debate, one that gets into the political arena, the congressional arena, et cetera. How do you manage all of that in terms of getting some level of finality at some point, or building a platform that allows you to modify over time?
Yes, sir. So, sir, to your first question, the good news is we have a new acting secretary who's well-versed in the F-35, and I'm sure that we'll learn a lot through that process. I have not studied F-35 to the degree I could, and that's a great recommendation. To your second point, this is why we wanted to put an operator over the top of it, a single individual who is charged with optimizing these key enabling technologies. One of the problems I believe, with a large bureaucracy, and the way we were structured in the past, is the Maneuver Center, for example, would develop a requirement for the next generation combat vehicle. We take it, throw it over the wall, and then the bureaucracy takes over. And there's no driver, there is accountability, but not a single point that's required, that is held accountable to drive that requirement forward. These cross-functional teams will report directly to the Undersecretary of the Army and the Vice Chief of Staff of the Army. So they will be held accountable, and they will be empowered, not unlike that slide that I showed earlier. I do think that what I'm trying to convey here with the idea of optimizing the 4+1 is to free up the director from achieving nirvana on each of the key enabling technologies. And due to the optimization, that is the sum of the parts of these 4+1, he's going to make a decision, when is it right to make an investment? And these are real complex decisions, but part of those is to some of our S&T maturity in some technologies might be well behind, but that director knows it's coming. And so one of the things he may want to do is allow that to be rolled in later, maybe 3, 5, 6 years down the road, not unlike what we did with the 120 millimeter on the M1 tank. That we made a decision when we got to a critical mass of key enabling technologies, and we moved, and we recognized that we would pull in the 120 millimeter later. We've got to do the same thing, but he will be charged with optimizing them to get an overmatched vehicle, not held accountable for achieving the threshold on all those enabling technologies. Does that answer the question? Sydney. Oh, sorry.
You mentioned the 2022 date, but sounds like that prototypes or concept vehicles or demonstrators or really convincing plastic models or something is actually going to be fielded and looked at, I'm not sure tested is the right word, before that date. So what's the timeline to actually see a vehicle or competing vehicles the way we are for future vehicle lift actually in the field being checked out?
So I'm be careful with this one, because I'm sure my bosses are going to have guidance for me on this one, because we're still working through this. My sense is it should be a function of where we're at on these. Because it's so expensive to do a developmental effort, we've got to be careful not to build a vehicle to just build a vehicle, because that's not a good use of resources. What you want to do is make a 10x vehicle. So it should be conditions-based and not necessarily time-based. The time horizon that we're seeing right now is that's a mark on the wall. We can move that left, and I suppose it's possible to move that right. But what we want to do is get to a critical mass of the key enabling technologies. So I wouldn't get fixated in time. Now, what do I believe? I believe that with combat vehicles and how they're developed, let's first look at what we have. We know that we've got the current fleet into the 40s, and we know we have engineer change proposals aligned to them. And if you play that out, if our current combat vehicles come to fruition in the late 40s, you've got to be fielding something by 2035, which means you've got to have a vehicle sometime in the early 30s. And so at the latest, at the latest, I would say that you're looking at something in the 30s, and that would enable us to replace our current fleet. It also probably is the most realistic when you look at the 10x efforts that we're looking at here. I suppose it's possible that some of them could come left. Sir.
Sir, can you explain what type of budget, funding, resource accountability the director of the CFT will have?
So I'll be able to deflect this one because the exhort isn't signed. So it's unclear on where the funding authorities specifically are going to be. We have an opinion on that, but that'll be signed out by the vice here before too long, or either the secretary and the chief. Right. No, and that's why I mentioned the authorities. Right. Two more questions, I think.
Just sticking with the topic of cross-functional teams, the implementing details of that obviously could be challenging. The team that you describe, whether it's acquisition, requirements, resourcing, and industry, have different kind of motivating and rewards mechanisms. How do you see kind of getting everybody into the same lane or focus versus how they operate today in order to achieve that?
Well, let's just talk about dynamics. What I believe to be true is that the closer you put together a team, the more likely you're going to be able to harmonize their motivations, intents, and rewards. So I could just start by saying that the dynamic that will play out when you pull a team like this together, rather than have them spread out all over. If I want to go to all the labs associated with NGCV, I got to go to 5 different states. It's really hard to create harmony when you're located across the nation. So the first point is bringing them together. The other thing is communication. And by virtue of being together, the communication improves. The third thing is I think we have to recognize what interests we all have. So obviously, clearly, that we want intellectual property and return is something I have to respect when I'm working with industry. Likewise, capability across the S&T effort is something that industry would. So I think that just building the team will improve a lot of that. Yes, but the details of that would be defined by the legal framework that we put together, and those are some hurdles we got to get through. I think there's one more. Connie?
Thanks. Connie, Inside the Army. Has there been any sort of preliminary look at what exact technologies you want to start off with? In the 4+1, for example, is there a specific APS that you're looking at to kind of start examining, and same thing for all the other ones?
So yes. So I'll give you a couple examples. So in terms of APS, we're already experimenting with off-the-shelf capabilities that you've probably heard of. Trophy is an example that we're looking at with the Abrams. I mentioned power. We need to look at fuel cell technology and electric power and invest money into that experimentation. So there's a number of systems that we are already experimenting with that are either off-the-shelf or we have S&T TRL levels that are sufficient to start putting together prototypes or tech demonstrators. Oh, no, we have not picked a specific APS. I think we've got some learning to do before. In fact, I expect it to be originally developed here or a combination thereof. Oh, I think that's it. So let me just finish up and close this out. First of all, thank you for attending the degree you did. What a great turnout. Second thing is I want you to know that the Maneuver Center is serious about taking the lead on the development of the next generation combat vehicle. We're going to develop the next generation combat vehicle at Fort Benning, Georgia, the Maneuver Center of Excellence, which is exactly where you want it to be developed, unlike what we did with the Bradley and the Abrams in the 70s and 80s. And then third, if you look at the trends on those 4+1 key enabling technologies, it's increasing capability relative to weight. And I think you saw the implications in each of those. Final point I would share with you is we look forward to collaborating with industry at Fort Benning and building partnerships down there. We think that we are cutting edge and driving the Army forward in terms of modernization. So please come to Fort Benning. I look forward to having you there. Thank you for your attention. God bless you.